Hello, and welcome to today's lesson where we're going to be working with trig functions to solve some application problems. And one of the biggest things we're going to be looking at here, because it is one of the biggest issues when students are setting up these application or word problems, is the idea of the angle of elevation versus the angle of depression. So now, when we look at the angle of depression, it's an angle that starts with the horizontal and goes down. So what I always like to think about is the fact that I'm looking at the angle horizontally, and then I'm looking down to create an angle of depression. Okay, this is not an angle of depression. Okay, an angle of elevation starts with the horizontal and then goes up. So if I'm looking at these two options, okay, the angle of elevation would be this angle here because I'm looking at the horizontal and then I look up for an angle of elevation. So you can see that that angle opens up for an angle of elevation. This angle opens down for angle of depression. Okay, so now just always remember that when you're given the situation so you can draw your diagram correctly, because that's the hardest part of these problems is setting up the initial diagram, because the rest is just using trig ratios and your calculator. Okay, so now the angle of elevation from a sailboat to the top of a 121-foot lighthouse is a measure of 16 degrees. Okay, to the nearest foot, how far is the sailboat from the shore? Okay, and that's the hard part. You can't necessarily measure distance as well. Okay, now with GPS, we can get a lot closer to it. But back in the past, they didn't have GPS, so how would they have done this calculation? They would know the height of the lighthouse, and they would use an angle of elevation, okay, from the horizontal looking up to the top of the lighthouse. And based on what that angle was, they knew how far they were away from the lighthouse. And they would have some charts and things that would help them do this calculation quickly. So now, if we're standing at the 16-degree angle and we label our triangle, the hypotenuse never changes. It's always across from the 90. The 121 is the opposite side, and what we're trying to find is the adjacent side. So we go through our trig functions, so, ka, toa. Okay, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And we see the pieces that we have. We have an opposite and an adjacent for what we're trying to solve and what we're given. So we're going to use the tangent of 16 degrees over 1 equals the opposite, 121, over the adjacent, x. Okay, you always want to set these up as ratios when you're given the angle measure, because we're going to have to cross multiply and solve, and sometimes it takes a little bit of extra work. Okay, so x times the tangent of 16 equals 121. Divide both sides by the tangent of 16. So x equals 121 divided by the tangent of 16. Okay, we type that into our calculator, and we're using the tangent function, not the tangent negative 1. 121 divided by the tangent of 16, and we get an answer of 421 feet from the shoreline. And actually, if we round it up, x would be 422 because it's 421.98. So 422 feet from shore. And then they would know, are they too close to a reef, too close to some type of sandbar that could end up scuttling the ship. Okay, now, looking at this second situation. Okay, this situation is what we call an angle of depression situation. Okay, we have the triangle here, but this isn't the first triangle that we would actually build. Okay, what we want to understand is we're working off of the horizontal, which is parallel to the bottom of the ocean. Okay, 11-degree angle of depression. So this is the actual measurement. Now, we can build two different triangles here based on what we want to do. Okay, we know that this situation, okay, we can build our pieces. The 39 meters can go here or here. Okay, so you get to pick where that goes. The 11 degrees can go where we put it here, or it can go down there, okay, because we have alternate interior angles. And what we're trying to find, x, can either go at the bottom or it can go at the top. So those are the two triangles that we can build, and you just want to make sure that you're building them accurately. And what you notice is the angle of depression from the boat down to the car is the exact same angle as the angle of elevation from the car up to the boat. Okay, but make sure you're diagramming it correctly, and then we can work through and solve from here. Okay, so now setting it up, I'm going to use the bottom triangle down here. So I'm standing at 11. 39 is the opposite, x is the adjacent. Okay, so we're using our tangent functions again. Okay, so we've got the tangent of 11 equals opposite 39 over adjacent x. Okay, set it up as a ratio, and then we cross multiply and solve. X times the tangent of 11 equals 39, and we're going to divide both sides by the tangent of 11, which remember is a number, so we don't have to use tangent -1 here. Okay, tangent of 11 degrees is an actual value, so if we want, we can use that value, tangent of 11 degrees, 0.1944, to solve this answer. So 39 divided by 0.1944. Okay, and we get our answer. Let's see how we want this rounded. Okay, we're not given a rounding rule. So let's round it to the nearest meter. To the nearest meter, x would equal 201 meters. Okay, last problem for today. How can we use trig ratios to find missing values? Okay, so the angle that we're trying to find here is the inside angle, which is a diagonal length from this point here to this point here. Okay, so we actually have to work through two triangles to be able to find that. Our first triangle is this triangle here. Okay, which may not look like it, but it is a right triangle. We've got a right angle in that corner. It's just the 3D drawing that throws that off a little bit. So the first thing that we need to find is x. So to find that length, okay, to find that length, what we have to do is use Pythagorean theorem. 8 squared plus 15 squared equals x squared. And then 8 squared plus 15 squared is 289. Square root both sides, and we get x equals 17. Okay, so now, from there, we want to find that marked angle. So now we know that x equals 17. We've got this value of 10, and we're trying to find angle theta right here. So if I'm standing at theta, 10 is the opposite, 17 is the adjacent. Okay, and we're going to use our tangent function here again. So the tangent of theta equals opposite of 10 over adjacent of 17. Now, the angle is what we're trying to solve for. This is when we use our -1 functions, or our inverse functions. We want to divide both sides by tangent to get theta by itself. And then, since we can't divide, we use our tangent -1 in that place to be able to solve this problem. So second, -1. Okay, so tan -1 of 10 divided by 17. Okay, and we get our answer of 30.5 degrees. Okay, so that is how we use trig ratios to solve application situations, and then also the application of the angle of depression and angle of elevation. Thank you, and have a good day.